Next, we'll move on to presenter Joe Levine.
Thanks.
Thank you, Christine. I'd like to talk about lunar dust and some knowledge gaps. Next, please. This photograph from Apollo 11, which is Buzz Aldrin's boot print in the lunar soil, lunar dust, has become a very iconic photograph. Next. Let me tell you about Neil Armstrong's comments as he was at the foot of the ladder on Apollo 11 on January 20th, 1969. And this is a quote: "I'm at the foot of the ladder. The lunar module foot pads are only depressed in the surface about 1 or 2 inches. Although the surface appears to be very, very fine-grained, as you get close to it, it's almost like a powder down there. It's very, very fine. I'm going to step off the LM now. That's one small step for a man, one giant step for mankind. The surface is fine and powdery. I can say I can pick it up loosely with my toe. It does adhere in fine, like powdered charcoal, to the sole and sides of my boots. I can only go in a small fraction of an inch, maybe 1/8 of an inch, but I can see the footprints of my boots and treads in the fine sandy particles." Little did astronaut Armstrong know that he was made the first measurements of what turned out to be a very interesting phenomena on the surface of the moon that we had not really anticipated or planned. Next. Next, please. We've talked about meteorite impacts on the surface of the moon and how the regolith is the surface layer and powdered and fractured rock was formed by meteoric action. We heard a very good review of lunar dust a little earlier by Ron Creel. Next. Let me talk about some lunar dust-related problems. One that hasn't been mentioned too much is vision obscuration. As Apollo 11, for example, was landing, the exhaust rocket on the lunar module blew up tremendous amount of dust into the lower atmosphere of the moon, causing some difficulty in seeing the surface. A second problem is false instrument readings, because dust resulted in overheating instruments. Number 3, dust coating and contamination, loss of traction to both astronauts and lunar rovers, clogging of mechanisms, abrasion and erosion of things like spacesuits, thermal control problems, failures of seals, and inhalation and irritation to the astronauts. Next. Let me give 2 quotes. This is Apollo 17 astronaut Gene Cernan. We've heard this before. "I think dust is probably one of the greatest inhibitors to a nominal operation on the moon. I think we can overcome other physiological or physical or mechanical problems due to dust. One of the most aggravating, restricting facets of lunar surface exploration is the dust and its adherence to everything, no matter what kind of material, whether it be skin, suit material, metal, no matter what it be, and its restrictive friction-like action to everything it gets on." That was from astronaut Cernan's debriefing. Next. The problems, though, continued even after liftoff from the lunar surface. This is Apollo 12 astronaut Alan Beam. "After liftoff, a great quantity of dust floated free within the cabin. The dust made breathing without the helmet difficult, and enough particles were present in the cabin atmosphere to affect our vision." Now, this is in the cabin on the way back to Earth. "The use of a wisp room prior to ingress would probably not be satisfactory in solving the dust problem because the dust tends to brush deeper into the garment rather than to brush off. Next, please. With these thoughts in mind, the NASA Engineering and Safety Center, which is an agency-wide program office located at the Langley Research Center in Hampton, Virginia, organized a conference on lunar dust and its impact on human exploration at LPI in Houston, February 11th to 13th. About a month before the meeting, NESC called me up and said they wanted to reschedule it for 2 months later. And I said, we can't do it. People already made their reservations and hotel reservations. And they finally agreed we should hold it as scheduled. Had we rescheduled it for 2 months, as suggested, we never would have had it because of the COVID-19 pandemic. You can see the sponsors of the meeting. Next. What I want to do is I want to talk about the meeting and talk about the information generated. In fact, our chair, Professor Hartzell, attended the workshop and in fact was in panel one. Panel one was lunar dust, composition, structure, and distribution. Panel two, the impact of lunar dust on human health. And panel three, the impact of lunar dust on human surface systems and operations and techniques / technologies to reduce / mitigate these efforts. And Michael Johansson was one of the co-chairs of that panel. Next. It turns out that the organizing committee invited about a dozen people to give plenary talks that lasted about a half hour, and we've got about 50 contributed abstracts. Everything is online, and that second reference, Program and Abstracts, has all of the material presented at that meeting, and in some respects, it's a treasure trove of our understanding of lunar dust. Next. NASA said they wanted two products of this meeting. The first is a NASA Engineering and Safety Center report that was released on September 24th, 2020, which summarized, it's about 60 pages. It summarized the discussions and conclusions. And then NASA also required a proceedings volume that was published earlier in this year by Cambridge scholars in England. Next. I want to give the address, the web address where you can download this NASA report, lunar dust and its impact on human exploration, and you can see the citation. And I think there are about 200 people at the workshop, and this summarizes in detail the results. Next. Just about a few months ago, the book was published, The Impact of Lunar Dust on Human Exploration, and so that's available now too. Next. The book is dedicated to Professor Brian J. O'Brien. Brian O'Brien designed and built and talked NASA into flying to the moon a dust detector experiment. It flew on Apollo 11, 12, 13, 14, and he collected a tremendous amount of data. Dr. O'Brien was the keynote speaker at the workshop, and he gave an outstanding summary. I asked him to write it up, but also include his personal approach to lunar dust. He actually trained the astronauts, and Dr. O'Brien wrote a 40-page manuscript, which was a personal account of his working with the astronauts, developing the lunar dust detector. Unfortunately, at age 86, Professor O'Brien passed away about 2 weeks after he submitted the paper, and we dedicated the book to him because of his pioneering work in lunar dust. Next.
5 minutes.
Oh, how many minutes?
5.
Okay. Now, I have identified some of the key questions that came out of panel number 1. Particle size distribution, chemical composition, mechanisms of cohesion, mechanisms controlling adhesion. Next. The thermal conductivity, magnetic properties, electrical charging, the effect of solar ultraviolet and solar wind, electrical charging of dust particles, electrical properties. Next. And optical constants, impact of volatiles, permeability and packing and other bulk properties. So there were 15 major areas that we have to work on: particle size distribution and movement of dust particles at all altitudes. Next. But what I want to end with is I want to talk about another dusty place for future human exploration. These are 2 photographs taken about 2 weeks apart by the Hubble Space Telescope of planet Mars. Next. There's a lot of dust on Mars. There are dust devils as a regular feature. Next. There are pictures from orbit that not only show the dust devils, but show the shadows of dust devils. Next. These are some tracks of dust devils. Next. On the surface of Mars, here's another shot. Dust devils on Mars. Next. This is Perseverance being lowered to the surface on February 10th of this year. Next. And here's a great shot, a photograph of Perseverance and its parachute that was caught during the landing. Next. I have a reason for showing you this. This is the surface of Mars showing where everything landed. And my final charters. Next, please. The reason I want to talk about this is there is a wonderful 3.5 minute video about the landing of Perseverance, showing the transport of dust on the surface of Mars, how it's being blown away. It's very, very similar to the case of the of lunar landing, and I'm suggesting that some of the people in this audience who are studying transport of dust may want to look at this video. It's a NASA video now on YouTube, showing the transport of dust on Mars, and use it to better understand what's happening on the moon when we land with Artemis in the hopefully near future. Thank you very much.
Okay, thank you.